Hi, I'm Ms. Lee. So you were asked to do a couple of practice problems. If you didn't get them right, well, here's your video showing you how to do these. So first things first, so if we follow the steps from the previous video, you're going to want to start by factoring out a greatest common factor. Well, is there a greatest common factor between these three terms? Well, they look like they're all divisible by 5. So yes, there is a greatest common factor of 5. We're going to go ahead and factor out a 5. So we have 5 times 3w squared minus, and then if you divide 6 by 5, you get 1. And if you carry the 1, you have 15 divided by 5, that's 3. So this is minus 13w plus 12. And then you make your big X, which I did already there for us. And then we have 3 times 12 in the top, so that's 36, and then minus 13 at the bottom. And so you think to yourself, what two numbers add up to negative 13 and multiply to 36? Well, you can pause your video and think about it for a second. All right, so you should have gotten negative 4 and negative 9. And what do you do with those two numbers? Well, we divide them by a. So I'm going to go ahead and divide both of them, not by 5, not by 15, but by 3. Okay, so you divide by the a in the equation, or the part of the expression where you had already factored out the 5. So you divide both of those by 3. Well, let's try and simplify these. Negative 4/3, that does not simplify, so we leave it. Negative 9/3, that simplifies to negative 3. And so then we do bottoms up, and so we have 3 times x minus 4, and then over here just a minus 3, and so that's basically like over 1, and so you have 1x, so I'm just going to put x, and then minus 3. Okay, so this 3 was this 3, this was this, and this minus 3 was here. Well, what did I forget? Yep, I forgot that greatest common factor. Don't forget that greatest common factor from the beginning. Always write that in. Okay, I also made a spelling error. That's a W over there. So it's 5 times 3W minus 4 times X, times W minus 3. Okay, and just to reiterate, this is the minus 3. This is the minus 4. Okay, for the second one, again, start by factoring out the greatest common factor. Well, I see that they all have n, so I know at least there's an n in the greatest common factor. I also see that they're all even numbers, so they're all divisible by 2. I'm going to go ahead and factor out a 2n. So if I factor out a 2n, 2n times what is 16n cubed? Well, that would be 8n squared. 2n times what is 12n squared? Well, 2 times 6 is 12, so it's plus 6. And then n times n is n squared, so 6n. Plus, and then 2n times what is 2n? Well, that would be 1. Okay, so again, we're factoring what's in here in parentheses, so I'm going to go ahead and make my big X. And at the top, I'm putting 8 times 1, which is just 8. And at the bottom, I'm putting 6. And so the two numbers have to add up to 6 and multiply to 8. So that would be 4 and 2. And again, we're dividing both of them by a. So dividing both of these by a, which in this case is 8. That's right here. So we're dividing both of those by 8. Then we simplify. This simplifies to 1/2. This simplifies to 1/4. And then we do bottoms up. So again, we start by putting our greatest common factor on the outside. We have 2n on the outside, and then we bottoms up. So then 2 comes up to be in front of the n. So we have 2n plus 1 times, and then 4n plus 1. And so then that's our factored form. So you have two ways you can go about checking this. You can go ahead and graph it in Desmos, or you can multiply it out. So just to be sure, I'm just going to go ahead and check this one real fast by multiplying it out. So to multiply the two binomials, I'm going to make a little box. And then I have 2n over here plus 1 here, 4n over here plus 1 here. So I have 8n squared and then 4n. Again, I'm multiplying into the box. So 2n times 1 is 2n. And 1 times 1 is 1. And so I have 8n squared plus 2n plus 4n, that's 6n, plus 1. And that's just from the binomials. Then if I multiply this by 2n, Do I get 16n cubed plus 12n plus 2n? Why, yes, I do. And so I've checked it. This does, in fact, equal this. And so this is the factored form of this expression over here. Okay, have a great day. Happy day.